The second lesson in the mole unit is on the molar mass of elements. We have two learning targets for this video. We want to be able to define molar mass and calculate the molar mass of compounds. And actually the second part of that learning target we won't hit up till the next lesson. We want to be able to use molar mass to convert between moles and mass of a substance. First of all, we want to define molar mass. A molar mass is simply the mass in grams of 1 mole of a substance. I want you to consider a question. Would 1 dozen apples have the same mass as 1 dozen grapes? And the answer to that is, of course, it wouldn't. Even if we had some really tiny apples or some really big grapes so that they were the same size, they still would not weigh the same because they're made of different substances. And I asked this question to make the point that all substances have a different molar mass. Even though we might have a mole of carbon and a mole of iron, so I have the same number of atoms of each, they're going to have different masses because they're different things. One's carbon, one's iron. If you recall how we define the atomic mass unit and Avogadro's number, which is our value for what a mole is, you'll recall that they are both based on the isotope of carbon-12. And there's a reason that that's done that way, that we define both the AMU and Avogadro's number from the same isotope. The reason why is that this allows the atomic mass to equal the molar mass, at least numerically. Now, the units are different, as you'll see in the example we're going to do here, but all we have to do is look at the periodic table, and we can find the molar mass of an element. So here's an example. Let's take a look at iron. If you look at the periodic table, you'll see the atomic mass of iron is 55.85 atomic mass units. Well, what that means is the molar mass of iron is 55.85, notice the number's the same, grams per mole. So every mole of iron has a mass of 55.85 grams. In other words, if I wanted to measure out 1 mole of iron, I don't have a mole counter, those don't exist, but we can measure mass very easily. So I'd go measure out 55.85 grams of iron, and that would be 1 mole of iron. So we have defined molar mass. Again, that second part there we'll hit up on the next video. Now we want to be able to take that molar mass and use it as a conversion factor to convert between moles and mass of a substance. So we're just going to jump right into some problems. I'm going to show you how to do them, and then after each one, I have a similar problem that you'll try to work on your own. So the first one, we have a lab procedure that calls for 3.00 moles of carbon, and we're asked what mass of carbon will you need. So notice here we're asked about the relationship between mass and moles. Well, that's a molar mass relationship. So look up the molar mass of carbon, look on your periodic table. You'll see the molar mass of carbon is 12.01 grams. And so what that means is 1 mole of carbon has a mass of 12.01 grams. That's our conversion factor. So how many grams are equal to 3.00 moles? We can use our conversion factor. Notice that moles cancel when I put 1 mole of carbon on bottom and then the 12.01 grams on top. So moles have canceled. We do the multiplication. Notice that's just 3 sig figs. 3.00 is 3 sig figs. So 36.0 grams of carbon would be our answer. Try this one on your own. What is the mass of 0.35 moles of krypton? So pause the video, work it, and then see if you get the same answer I do. Well, this is essentially the same question as we had before. We're asked about the relationship between mass and moles. So we need to look up the molar mass of krypton. Look at your periodic table. You'll see it's 83.80. So 1 mole of krypton has a mass of 83.80 grams. So starting my problem the same way, how many grams equals 0.35 moles of krypton? I can use that molar mass as a conversion factor. Again, notice moles go on bottom, and it's 1 mole of krypton, not 83.8. 1 mole of krypton has a mass of 83.8 grams. So moles of krypton cancel. That gives us 29 grams of krypton. Let's look at the next question. How many moles of barium are present in 59.08 grams of barium? Ask yourself, how does this question compare to the last two we just did? If you said it's the same relationship, but it's the reverse question, you would be correct. In this case, we're asked to find moles given a mass. Before we were asked to find mass, we were given moles. So it's the same relationship, so we still need a molar mass. So look that up on the periodic table. The molar mass of barium is 137.33 grams of barium in 1 mole. So this time we're looking for moles, starting with a mass. So notice when we use our conversion factor, the molar mass number, the 137.33, is going to go in the denominator of our conversion factor. So the grams of barium will cancel, and we're left with moles of barium, which is what we're looking for. And notice here we get 4 sig figs, and I get 0.4302 moles of barium. Determine the number of moles in 30 grams of aluminum. Go ahead and try this one yourself. Pause the video, work it, see if you get the same answer I do. So this is essentially the same question we just had in the last example. It's a question between the relationship of moles and mass. So we need a molar mass. Molar mass of aluminum is 26.98 grams of aluminum in every mole. So we want to find the number of moles in 30 grams. So I'm going to use my molar mass as a conversion factor. So notice my mass, my 26.98 grams of aluminum goes in the denominator, so the grams will cancel. And I'm left with moles, and that gives me 1.11 moles of aluminum. So you've seen 4 examples here of the basic conversions between mass and moles using a molar mass. I'll remind you that in the first lesson we had a flow chart that helped us try to identify some of these conversions. I want to show you what that flow chart would look like now. So here's a summary flow chart for what we've just seen. If we're converting between moles of A, where A is any substance, and mass of A, we use the molar mass. We always use the molar mass of A. Now for an element, as we've seen today, we just look it up in the periodic table. In the next video, we'll see how we deal with compounds. There's one more step we have to deal with. We actually have to calculate the molar mass, but for now we're not concerned about that. Now I'll also have you recall in the last video, we learned about converting between moles and particles. So if we add that to this flow chart, I'm going to click on a new screen here. If we add that to the flow chart, so here's what we just had, conversion between mass and moles. Recall we learned in the last video that to convert between moles and particles of A, we use Avogadro's number. So notice we could go either way for moles. We could go to a mass of A if we use the molar mass. We could go to the number of particles if we use Avogadro's number. So certainly we should be able to answer questions like that. So let's take a look at how that might look. So here's our question. Determine the number of atoms in 50 grams of tin. Now even though we're not asked to find moles here, we are going to need the molar mass. The reason I know that is because I can't convert straight from grams into atoms. I don't know the mass in grams of a single atom of tin. But however, I can go to moles, and I know how many atoms are in a mole. So if we look at the molar mass of tin, we'll see it's 118.71 grams of tin for every mole. And this is what we're trying to do, finding the number of atoms of tin in 50 grams of tin. So I'm going to start my problem with 50 grams of tin. Now I can convert from mass into moles. I can't go straight to atoms. And to do that, I just use the molar mass that we look up on the periodic table. Every mole of tin has a mass of 118.71 grams, so grams will cancel. I'm left with moles. Now ask yourself, how do I go from moles to atoms? Well, remember, a mole is a counting unit. It has the same number of particles in it every time. 1 mole of tin would contain Avogadro's number of atoms, 6.022 times 10 to the 23rd atoms of tin. So notice moles cancel. And that gives us 2.54 times 10 to the 23rd atoms of tin. Next question. Calculate the mass of 5 times 10 to the 15th strontium atoms. I want you to pause the video and try this on your own and then see how you do. So you'll notice that this question is the reverse of what we were just asked. On the previous question, we were asked to find the number of atoms given the mass. Here, we're given the number of atoms, asked to find the mass. So we will need the molar mass of strontium, even though we're not asked about moles here. We need to convert to moles as an intermediate. So the molar mass of strontium is 87.62 grams of strontium for every mole. Here's what we're trying to do, finding the mass. Notice the question asks to find the mass. It doesn't ask specifically for grams. So you could really give the mass in any unit you wanted to. However, as you'll see, the gram as the unit for mass is always the most convenient because that's the unit on the molar mass, grams per mole. You could be asked, say, to find it in milligrams or kilograms. In that case, you'd have to do another conversion. But if you're not asked for a specific unit of mass, I would use grams because that will be the most convenient. All right, so started with our 5 times 10 to the 15th atoms of strontium. If I want to go to grams, I can't do that directly because I don't know the mass in grams of a single atom of strontium. So I need to convert to moles. I know that there are 6.022, again, Avogadro's number, times 10 to the 23rd atoms of strontium in every mole of strontium. So atoms cancel. Now I can use the molar mass. I know 1 mole of strontium has a mass of 87.62 grams of strontium. Moles cancel, and I'm left with grams, what I'm looking for here. Notice only 1 sig fig here. 5 times 10 to the 15th is 1 sig fig. Plug that into your calculator. Should round to 7 times 10 to the negative 7th grams. Ask yourself, does this answer make sense? That's a very small mass. Well, if you think about the number of atoms we have here, this is way less than Avogadro's number. It is 10 to the 8th times less than Avogadro's number. In other words, I have 10 to the 8th times less than 1 mole of strontium. So it's going to be way less than the molar mass of strontium, and obviously that is. So in this video, we have used molar mass to convert between moles and mass. In the next video, it's actually going to be the exact same learning targets, except we will be looking at calculating the molar mass of compounds, how we deal with that, and then we'll be looking at some examples of those calculations, really that we've just seen here, nothing different on that front.